Let me tell you something amazing. Imagine a robot that can deliver packages in the wee hours of the morning, restock restaurants, or meet any need at any time of the day or night. That's exactly what Tesla's Optimus is getting closer and closer to doing. A few days ago, without an official announcement or a splash video, Tesla quietly released new images showing the latest Optimus arm architecture. It was easy to miss, but the change is huge. We're talking about an arm that's 25% lighter, much more precise, and with the ability to adjust force at every microscopic step of a task. Now, imagine this scenario. Optimus watches a single tutorial on motorcycle engine repair. He then grabs a wrench, disassembles the entire engine, and then rebuilds it perfectly. No other robot comes close. As Elon Musk himself often emphasizes, while most robots rely on rigid programming or remote control, the Tesla bot learns on its own, at an accelerated rate. Just provide it with a few videos, and it can absorb up to 100 new skills in a single day, from adjusting fuel injectors to changing spark plugs without ever repeating the same mistakes. The most interesting thing is that the Optimus Gen 3 is no longer a laboratory prototype. It's practically ready to roll straight out of the Texas factory. And the big question is, why did Elon Musk choose to unveil this evolution so quietly? And more importantly, why the obsession with perfecting the hands? Well, the new Tesla Bot Gen 3 design boasts a whopping 22 degrees of freedom. To give you an idea, it'll even be able to play the piano. That's truly impressive. Tesla introduced a new shoulder and arm system that replaces the old two-hinge mechanism with a ball joint with an integrated harmonic reducer, allowing for true 3 degrees of freedom. This gives the arm the ability to reach tight spaces and move at virtually any angle with precision, greatly expanding its range of action. At the heart of this advancement is an ultra-compact harmonic reducer, embedded in the joint itself, capable of delivering high torque density with virtually no backlash, while reducing actuator mass by more than 25%. The system also features regenerative braking, which reuses kinetic energy, increasing energy efficiency and extending operating time. Around the joints, embedded sensors measure force, torque, and movement in milliseconds, enabling extremely refined control. This means the robot can handle fragile objects delicately, but also lift heavy loads with certainty, switching between different tasks effortlessly. All power, data, and pneumatic wiring is routed internally, protecting the systems and facilitating maintenance. Furthermore, the external structure was constructed from a lightweight magnesium and aluminum alloy reinforced with carbon fiber, further reducing weight by 25%. The result is a more agile robot with lower inertia, capable of carrying up to 7 kg with the same fluidity as previous versions, which only carried 5 kg, and still with 20% greater efficiency. This cleaner, safer, and more functional design isn't just an update, it's a technological leap forward. Optimus Gen 3 is equipped to perform high-precision assembly, logistics, industrial tasks, and even domestic support, with a mastery that places it on a new level of humanoid robotics. And of course, all of this is only possible thanks to Tesla's artificial intelligence system. With its advanced neural network and computer vision, Optimus can learn complex tasks just by observing them once. Imagine showing your robot a video of your favorite musician playing a song. Optimus analyzes every movement, every chord, and every rhythm, and then teaches you to play naturally, as if it were a private tutor. The most incredible thing is that, to accomplish all this, the central point lies in the hands. Musk often says that without legs, a robot can still be useful, but without hands, it's nothing more than a metal shell. It's no wonder Tesla invested so much energy in this aspect. The hands' actuators and sensors were designed from scratch, based on fundamental principles of physics. With 3D cameras and ultra-sensitive sensors, Optimus can even function as a guardian inside the home, patrolling environments and identifying obstacles such as furniture, animals, or people. And when placed in complex industrial settings, such as Tesla's own factories, the robot is capable of mapping the environment, calculating routes, and moving safely and efficiently. This evolution of the arms from Gen 2 to Gen 3 represents not only a design advancement, but a true transformation in the range of tasks Optimus can perform. This is particularly true because of the hands, which are now among the most sophisticated ever created in humanoid robotics. When I analyze the arrival of Gen 3, it's clear to me that Tesla has successfully transformed Optimus from a simple experimental prototype into a true multifunctional agent, equipped to perform thousands of tasks with much greater speed and precision. This leap forward comes thanks to twice the degrees of freedom in its arms, extremely advanced sensors, and full integration with Tesla's own artificial intelligence and batteries. The result is that the robot is no longer just a walking torso, but a versatile partner, ready to take on everything from household chores to the most complex everyday challenges. And Elon Musk doesn't hide the importance of this evolution. He makes it clear that the Tesla Bot Gen 3 isn't just an incremental update, but rather the heart of the company's strategy to redefine not only mobility, but also the very notion of work. From the first public demonstrations to private conversations with his engineering teams, Musk has treated Gen 3 as a watershed moment, the moment when humanoid robotics leaves the research labs and enters the real world. He himself acknowledged that redesigning Optimus was one of the most difficult tasks of the entire process. It wasn't enough to simply tweak details here and there. It was necessary to rethink every actuator, every joint, every cable, taking into account cost, reliability, and, above all, feasibility for mass production. For Musk, true success won't be measured by prototypes displayed on stage, but by the thousands of robots rolling off the assembly lines. Earlier this year, Tesla quietly completed the first Gen 3 prototype, assembled from over 1,000 unique components at its Fremont factory. Musk celebrated this milestone by saying that Optimus now truly has the potential to perform a wide variety of tasks. He even revealed that the public release won't be a theatrical showcase for investors, but rather the debut of a product ready for real-world testing, featuring water-resistant hands, more efficient motors, and optimized power management. And the production plans are bold, to say the least. Musk revealed a goal of manufacturing 5,000 units by the end of this year, with parts already reserved to reach 10,000 to 12,000 robots. He even joked that if Tesla could deliver half that, it would still be a historic feat, comparable to the size of a Roman legion. And he went further. He projected a target of 10 legions, or about 50,000 units, for next year. His predictions suggest that this number could reach 100,000 by 2026, and by 2027, 500,000 or even 1 million robots per year, with the ultimate ambition of scaling to over 1 billion annually depending on global demand. These numbers are impressive, but they reflect Tesla's confidence in its production ecosystem, which includes gigafactories, in-house battery manufacturing, and the repurposing of electric car components to reduce costs and accelerate production. The plan to bring the Gen 3 to market is also straightforward. First, deploy approximately 1,000 robots within Tesla's own factories later this year to perform repetitive tasks like organizing 4680 cells or moving materials. For Musk, this phase is essential. While testing the robot's reliability and continuous use, it serves as a practical proof of value for future customers. Starting in 2026, the plan is to open sales to the general public, along with a rental program for companies needing on-demand robotic labor. This demonstrates Musk's vision that robots will first prove their worth behind the scenes, on production lines, before finally arriving in people's homes. In virtually every speech, Musk reinforces the same point. The Gen 3 is Tesla's most important product. He argues that while a car spends most of its time parked, Optimus will be able to work for hours every day, taking care of household chores, participating in industrial production, assisting in hospitals, and perhaps even on space missions. His vision is bold. Musk believes that in the future every person will have at least one of these robots at home, and he goes further, predicting that Tesla will reach a $25 trillion valuation on the back of this product. According to him, Optimus will surpass all of Tesla's other businesses in importance by at least 10 times. And it's not just about hardware. Musk makes a point of highlighting that the Gen 3's greatest strength is the complete integration of mechanical design, artificial intelligence, and mass production. It's this combination that, in his view, will transform Optimus from a futuristic promise into a present-day reality.